Although the terms thermal mass and density are sometimes used interchangeably in everyday conversation, they describe two very distinct physical properties. Understanding the difference between them is crucial for architects and engineers because it influences how buildings store, release, and regulate heat over time. In this video, we'll go over density, specific heat capacity, and how these two shape a material's thermal mass. Density is a fundamental property of matter that expresses how much mass exists within a given volume. In simple terms, it tells us how heavy a material is for its size. Mathematically, it is defined as P equals m divided by v, where P, or the Greek letter rho, represents density, m is the mass of the material, and v is its volume. For example, a cubic meter of concrete weighs about 2,400 kilograms, while the same volume of water weighs around 1,000 kilograms, and wood or CLT might weigh only 400 and something kilograms. Concrete is therefore denser than water or wood because more mass is packed into the same space. Density alone, however, does not tell us how a material will respond to heat. It only tells us how much material there is. Thermal mass, on the other hand, refers to a material's ability to absorb, store, and release heat energy. A material with high thermal mass can take in a lot of heat without changing temperature rapidly, then release that heat slowly over time. This property helps regulate temperature fluctuations in buildings and natural systems. Thermal mass depends on several material properties, but primarily on density and specific heat capacity, which is the amount of heat energy required to raise the temperature of 1 kilogram of a substance by 1 degree Kelvin or Celsius. To simplify it, we can think of a material's thermal mass per unit volume as being roughly proportional to thermal mass equals P times C, where P is the density of the material and C is the specific heat capacity of the material. Let's compare two materials, aluminium and water. Aluminium has a density of about 2,700 kilograms per cubic meter and a specific heat capacity of about 910 joules per kilogram times K. Water has a density of around 1,000 kilograms per cubic meter and a specific heat capacity of around 4,180 joules per kilograms times K. Using the relationship above, we can estimate their volumetric heat capacity, which is thermal mass per cubic meter. Aluminium gives us 2,700 times 910, which gives us 2.4 million joules per cubic meter times K. Water gives us 1,000 times 4,180, which gives us 4.1 million joules per cubic meter times K. So even though aluminium is much denser, water actually has a higher thermal mass because it can store so much more heat per kilogram that it also stores more heat per cubic meter. This is why water is so effective in moderating temperature. This is also one of the reasons why water is often used for cooling computers. In building design, materials with high thermal mass, such as concrete, brick, or stone, are often used to stabilize indoor temperatures. They absorb excess heat during the day and release it after sunset, reducing the need for artificial heating or cooling. In contrast, lightweight materials like timber or insulation foam have low thermal mass, so they respond rapidly to temperature changes. These are useful when you want to minimize heat storage, such as in lightweight, well-insulated buildings. To summarize, density tells us how compact a material's mass is, while thermal mass tells us how much heat that material can store. Although the two are related, since denser materials tend to have higher thermal mass, the relationship is not one-to-one. The key difference lies in the material's specific heat capacity, how much energy each kilogram can hold. So, while a dense metal like lead feels heavy, it does not necessarily have a high thermal mass. In contrast, water, which is less dense but has a very high heat capacity, is one of the most effective natural thermal storage materials known. Thank you for watching this video. Make sure to subscribe if you've enjoyed and want to learn more about other topics related to our build environment. Stay informed, stay inspired. TimberTalk.